Thank you very much, Mr. Chairman. Dr. Spudis, in your testimony, you state that the United States abandoned the strategic goals for space set by Vision for Space Exploration in 2010 and eliminated the objective of a lunar return. The elimination of lunar return has left a vacuum in the national space exploration policy that has yet to be filled. Should the United States return to the moon and cislunar space, and if so, how does that fit, in your opinion, within a longer-term human exploration strategy?
Well, yes, sir. I do believe that the moon played a critical role in the original vision for space exploration, in that it was a key enabler. It both enabled you to create the technology you needed to go deeper into space beyond low Earth orbit, and it also offered the ability to create all new capabilities, such as the provision of consumables and propellant from lunar materials. So for this reason, I've advocated lunar return for a long time. The more we learn about it, the more promising it appears as a target. And you have to be able to build a system in an incremental manner using small steps, so that you don't necessarily have a big wedge of money that you need to get started, but at the same time you create long-term capability. So in my opinion, focusing on the development of cislunar space and specifically development of the resources of the moon actually can create new capabilities that we currently don't have, and that includes the capability to go to the planets.
Yeah, virtually, and I may have forgotten some who didn't, but virtually every witness we've ever had come before this committee has said we need to have a lunar base as part of the stepping stone. The only one we haven't got that yet from is NASA. Dr. Spudis and Dr. Sommerer, can you discuss what are the most important elements of the planned cislunar habitat that feed into the longer-term plan for the journey to Mars? What key technology development and scientific research can be done there that will feed the forward to a human mission to the Martian system?
One of the salient features of a mission to the Martian system is how long it takes, given our current propulsion capability and those we foresee. It could take years, okay, at least a year. We've learned a great deal about environmental control and life support systems as part of the ISS. However, and I have this on authority from the engineers who are responsible for that, it's kind of a kludge. There's a lot of things that have been put together over time. They aren't totally compatible. I would think, if you're an astronaut on your way to Mars, want to believe that that environmental control and life support system was going to be very reliable, not require constant maintenance, and was going to get you there safely. That's one of the things that you could do in cislunar space. You could develop that capability in cislunar space, where you're only 3 days away from help if something does go wrong. That would be a very, very important contributor to Mars. The other thing that you can't do on the ISS is deal with galactic cosmic rays, because it's at such low altitude and deep in the Earth's magnetic field. We need to have a lot more experience with what radiation does to people on long-duration missions. That's something also that can happen in cislunar space, where people are pretty close to help if things are going badly. Yeah, those are two things that I think are absolutely critical.
You know, I'm a son of Apollo. When they did all that without computers, they did it with slide rules. You know, as President Kennedy said, great nations do things because they're difficult, because they're hard, actually. He said, not because they're easy. And certainly this falls in that ballpark. Dr. Spudis, it's my understanding that commercial lunar mission backed by private sector investors could be launched to the moon as early as next year. As an advocate of lunar resource development, do you see value in commercial robotic missions, and do you think NASA could benefit from including payloads on those missions?
Yes, I do. And I should preface this by saying I'm involved in one of those commercial companies. I advise Moon Express Incorporated on possible payloads. But in actual fact, there's a lot that you could accomplish with small robotic missions to help prepare the way for both human return and the development of lunar resources. For example, if you were able to fly a set of instruments that could measure surface hydrogen on a small lander and land it near the lunar poles, that is a key critical piece of strategic information that we don't have. It would also allow us to calibrate the remote sensing data that we have. I think it would be a very good investment of NASA funds to help provide instruments like that to any of these commercial missions for the simple reason that it's a cheap and inexpensive way to get very valuable long-term strategic information.
Okay, and for you and Mr. Young, as seen with the success of the commercial cargo program and the progress being made with the commercial crew program, can you discuss in more detail how NASA can leverage public-private partnerships as human exploration program extends beyond the low Earth orbit?
It's a broad question. As I said earlier, industry is a critical component of the exploration program in partnership with NASA. The commercial activity, I'm going to use commercial cargo as an example. In that particular circumstance, NASA or the country has turned a lot of the responsibility over to the commercial supplier. And I think in that instance, it was a good thing to do, and it was a good decision. I think we've got to be careful when we talk about exploration as to how we use the term commercial. And what I really mean by that is I think it's going to take the best of NASA, the government, and industry to do a human to Mars mission. And we should not do commercial experiments as a part of that endeavor. So I don't know whether I've specifically answered your question or not, but I think there's a spectrum where commercial makes, the real term commercial makes an awful lot of sense. And there are other activities where the nation has to provide the leadership from government with industry being an implementing partner to make things happen. So that's what I was trying to say. If I could, I know I'm cheating, but if I could make one comment on cislunar space that you talked about, I think there are things, and I agree with the Kennedy statement, which I think was good, but I think there are things that can and should be done in cislunar space that are necessary in order to have a human to surface of Mars mission with an acceptable probability of success. However, my caution would be we don't need another space station in cislunar space that is basically going to be carrying on an R&D program there. And I think that was your implication also. So I think that, again, the plan we keep talking about will allow us to make the judgment as to, in cislunar space, what is required, and we need to separate that from what we can do there, because what we can do is probably not necessarily what needs to be done. So
Right.
I think cislunar space needs to be planned very well, or it itself can become an enormous user of this resource that we're talking about.
Thank you, Mr. Chairman.
Yes, sir. Great line of questioning there. Now